So hello everyone. In this particular video, we are going to discuss a particular problem which is from a Leetcode, and the problem is find in mountain array. So this is a very interesting problem, and we will see how this problem is related to the particular problem that we have solved earlier. Okay, so the problem is something like that. You are given a mountain array. Suppose you are given some mountain array and you have to find some element in the mountain array. Earlier, when we solved the problem of binary search, we are just given an array which is sorted. So we are able to find the particular element and return the index of that particular element. But now in this problem, we are given a mountain shaped array. Okay. So the element of the array is forming the mountain. And then we have been asked in this particular problem to find the index of a particular element. Okay. So you can clearly see that this particular problem cannot be mapped directly with the binary search because the array is not sorted, so we cannot apply the binary search. Okay. So suppose we are given an array like that, ARR, and there are certain elements. Suppose the first element is 1, the second element is 2, then 3, then 4, then 5, then 4, then 3, then 2, and then 1. Okay. So these are the elements that are present in the array. So let me do the indexing. So 0, 1, 2, 3, 4, 5, 6, 7, and 8. So there are 9 elements and we have done the indexing. So you can clearly see if I plot the graph using indexes as a x-axis and the element as a y-axis, so I will get a mountain. Okay, I will get a mountain. And in this particular question, we have to find the index of a particular element. Suppose I want to search for 4. So there are two places where 4 occurs. The first index is 3, the second index is 5. So we have to return the minimum of that. Suppose for this answer will be 3 because out of 3 and 5, 3 is minimum. Suppose we are given a question in which the target is suppose say 2. So we can see that 2 is here and 2 is here. So the answer for that will be 1, obviously, because 1 is lesser than 7. So this is a question. Now, how can we solve this particular problem? That is the question. How can we solve this particular problem? And believe me, this is a hard question of Leetcode. Now see what is the basic science behind people, those who are making the question. They are just using multiple concepts and they are just adding those concepts in a single question and they are just putting on the platforms like Leetcode, Code Forces and something like that. So they are just using the basic concept. What basic concept? In previous video, we have solved find index of peak element. If you have not watched that particular video, please go and do so. It will greatly help you. So find index of a peak element. Now, peak element can be the maximum element as well. So there can be a problem where you have to find the maximum element in a mountain array. Obviously, the answer will be the peak element. This point in a graph will be the peak element. Now, what can you, if you are able to get the peak element and the index of that peak element, what can you guarantee from that? My question is that if you are able to somehow get this peak position, how can you solve this particular problem? Okay. Now, let's see how to build an intuition. Suppose you have been given this problem in an interview and you have not solved this problem previously. So you have to think at random. Okay. So how will you think? You have solved the problem similar to this, which is find the index of a peak element. Now, can you map this problem with the same problem that you have solved earlier? This is the way. Believe me, you can't solve all the problems. You have to map the problems with the different problems that you have not solved, and also the problem that we have solved as well. Because if you are able to map the problems that you have solved to the problem that you have not solved, then only you can get the intuition behind solving the particular problem. Suppose if you have not solved the problem of LIS, then there will be a high chances that you are not able to solve this particular problem and the problem related to LIS, which is longest engaging subsequence. So if you don't know about LIS, there's no problem. We are not going to discuss LIS in this particular video. We will do in the dynamic programming lecture. So how can we map this particular problem? So you can clearly see that if I can break this problem into two parts, I can break this problem in from the peak position, and there are certain elements which are left to the peak element, and there are certain elements which are right to the peak element, and there is some property that are being holded by this particular element of the array. So suppose 5 is not suppose 5 is the peak element in this particular array. So from 0 to this position, the array is increasing, and from 5 to 8, it is decreasing. So this is a point where they just change. There is a change in the curvature. If you have studied maxima and minima, so there is a concept of a curvature. So here there is a change in the curvature. Okay, there is change point. This is a change point. So we can find this change point very quickly because we have solved the problem related to that in a previous video. Now we want to search particular element. We can use binary search here, and we can use binary search here. This is sorted in increasing order, increasing, and then this is sorted in decreasing order, decreasing. Okay, we can find the element and then we can return it. So what we have done, first find the peak position index, okay, and then do binary search here, left side as well as right side. You can include 5 either in the right side or in the left side, no problem. But you can solve this problem very easily using the big concept that I have told you. So this is a simple binary search problem, nothing else, and this is a hard question. This is a hard question of Leetcode. The people who have made the question, they have the basic science behind the questions. They are just collecting multiple concepts and they are just putting that particular concept in a particular problem, in a single problem, and then you have to solve that particular problem. So this is the way that problem is being solved. I think if you have watched my previous video, this problem is just a cakewalk for you. Just a cakewalk. If you have watched my previous lecture, previous video, believe me, this problem can be solved in just 5 minutes. Just code binary search for increasing function, code binary search for decreasing function, find peak element, then return the minimum of the indexes. That's it. We don't need to do anything in this particular problem. Okay, so I think this is enough for me to explain you this particular problem, and if you want, we can code it. First, we are going to write binary search for increasing function. So for increasing function or array. Okay, so we have done multiple times. So int, it will return the integer, and let's say we want what we can call, let's say we call left. Okay, so we pass in the array reference, suppose ARR. We can also pass low and high. Okay, no problem. Now while we have a single element, we will process. So while low is less than or equal to high, what we need to do, first we find the mid. So int mid, assign low plus high divided by 2. So this is how we find mid. And Then we compare if the current element which is pointed by mid, if it is equals to the target. So we have not taken the target. So first let me take the target as well in target. Okay. Then if it is matching with the target, if it is equal to the target, it simply return the mid. Okay. This is how we do it. Else if the array at mid position is greater than the target. So if this is the case, so the left part is not, right part is not relevant to us. So we will assign highest sign mid -1. And if the target is greater than the array of mid, then we simply do assign mid +1. Simple binary search. And finally, what we do, we return -1 if we are not able to find the particular element. Okay. So if this statement will not execute, we will return -1. Now we are going to write binary search for decreasing function. So binary search for decreasing function. Okay. First, think we actually need to write it, or we can simply copy paste this. Just copied and pasted. Okay. Change the name from left to right. Okay. And think what we have to change. Just one condition. From this greater than sign, just change it to less than. Only this is the change if you want to write for a decreasing function. And the rest will be done by it automatically. Okay. Now we are going to write the peak position. How to get? It will return an index. Let me write peak. It will take vector of mountain. So I call it array. And let's say site. Okay. And simply what we had to do, we have to just find the peak element, the same coding logic that we have used in the previous video. So int low, we will define search space. And in the case of array, we have low and high, which is pointing to 0 and n-1 respectively. Now, if there is a single element, we will process while low is less than high. Now, there are certain cases that we have to check. First, find mid, int mid, assign low plus high divided by 2. Okay. We have find the mid. Now, we have to check certain cases. The first case is for peak. Okay. For peak position, what is the condition? So we have to do simple checks. If element at mid position is greater than element at mid -1th position, so mid -1. If this is the case, and array at and element at mid position is also greater than element at mid +1th position. If this is the case, simply return mid. Okay. Simple. Now, again check. If array of mid is less than array of mid +1. Okay. If this is the case, so we simply assign low sign mid +1 because we are increasing part and the answer will not lie in the downhill. So that is why we are moving our low to mid +1th position. And else we are simply doing high assign what? Mid -1. Okay. Or simply return -1. Even we can return low as well. No problem. Okay. So this is a simple function finding peak. Now what we have to do? So let's take some input. So int n, size of array, as well as target, sen n and target. Okay, so we have a vector that will denote the mountain array, and let's call it array of size n. Then we are going to take the input. So int I sign 0 till I less than n and I plus plus. Simply we are going to take the input. So sen array of I. So we have got our input, we have got our target. Now it's time to solve the particular problem. So we have made this function to solve this particular problem. So what we can do, simply we can first find peak position, as we have seen in the lecture part. Let's say we call it idx. So peak, then we have to pass the array as well as size. We have got our peak index. Now we can simply do binary search. So int L, that will store the value, left. Then we are going to pass what array. Then what will be the low? So low will be from 0 and high will be idx and target will be the target. Okay. So what we are doing, suppose we are in mountain array like this, and we have got this peak index. Okay. Now we are searching in this part, including peak. Okay. We are including peak in this as well. So we will not use peak here. And then we will search in this part. So this is our left part. This is our right part. Then we will perform searching. So suppose this is 0, this is n, this is peak, not n, it will be n minus 1. Okay, this is peak. So for the first part, we will provide what? Low to be 0 and high to be p. And for right part, we will provide p plus 1 and then n minus 1. Same. This will. So this is what we are doing here, and this is what we will do. So I think you have got my point. Then again, int right side, that will be the right ARR. Then we have idx plus 1, and then we have target. Okay. Okay. So let me call it P. Okay. This will look some fine. So P and P plus 1. Okay. It looks good. Okay. Now we have to do simple checks. What? If L equals to minus 1 and R equals to minus 1. Okay. If this is the case, then we have to what? We have to print cout minus 1 and L. Okay. If this is the case. Else if suppose L equals to minus 1, so we are not getting the element in the left side, but we are getting the element in the right side. So R not equals to minus 1. We are going to just print R, because that is the position where our element is going to lie. Okay. Else if what? Suppose we are getting the element in the left side but not in the right side. So L not equals to minus 1 and R equals to minus 1. So we are going to print the left position. So left and L. Okay. L. And suppose we have got the element. Suppose we have got the element in this part as well as in this part. Okay. So we have to print the minimum of that. Okay. So we can simply do by else cout minimum of L and R and L. Okay. So that will be the answer. So let me take the input. So there are 9 elements. 1, 2, 3, 4, 5, 4, 3, 2, then 1. Okay, so there are 9 elements, and the target is, suppose we have seen the target as a 2, so the answer should be 1. So it should be printed over output.txt. Okay, so let me run, hope that it should work fine. But if it is not, then we will check where we have done wrong. So p plus 1, so we have to put n minus 1 because it requires one more argument, and I think rest everything is fine. So 0 and 1, suppose we are going to search for 10, which is not present in this particular array, so it should return minus 1. So minus 1. Okay, so it is working perfectly fine. So let's see the question in the Leetcode. So we have copied this particular part, and then we are going to just paste in the question. So here there is a problem, find in a mountain array. So first let me paste the functions that I have written. Okay, so this is a problem. This problem is an interactive problem. So we will see how this problem is an interactive problem. You can recall that an array is a mountain array. If so, we have seen the property of mountain array. Now, given a mountain array, return the minimum index such that mountain array dot get index equals to target. So in this particular problem, we have used array of mid because we have access to that. But here we have given the class mountain array. We have a public interface. So we have two functions, that is get and the length. So get is something like that, and length is the size mapped with the array. Okay. So in all the places where we have written array of mid, we have to change it to array dot get mid. Okay. And instead of size, we will use length. Just. Okay. This is the only change that we have to do, and the problem will be the same. We will see how. Okay. So you can go through the problem, and then you can just use my approach, which I have told to you. So let me make the essential changes. So instead of array of mid, we can simply do array dot get, and we have to do simple what? Mid. Okay. Okay. Where we are accessing mid. So here also we are accessing mid. So array of just get dot get mid. Okay. And where we are accessing here. So again, just get mid, and here as well dot get mid. Okay. And where else? So we are accessing here. So let me make the changes here as well. Okay. 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 So, and here we are using our array, vector int array. So instead of that, what we can do, we can pass the mountain array. Okay. So also let me copy it, and instead of vector int, we are just passing mountain. Okay. So we have this particular class. So we just need to modify some of the data. Let me copy. Okay. Here also we have to do the same. Just copied. Now it looks fine. Okay. So int n, what we can get? Mountain array dot length. So we have the length property. So we can access that. Dot length, we have a public function length. So we can access that. So we can simply copy paste the code that we have written earlier. Okay. So these codes we are going to just copy and paste. So just copied and just pasted over here. So in this particular problem, we do not have to print, just we have to return. So instead of print, we are just going to return -1. Okay. So here we have to return R. Okay. Here we have to return L. So just return L. Okay. And here we have to just return if the above code have not returned it. So this will return it, minimum of L and R. Okay. So let me run it. I think this should work fine. So here we have done the get mid. Okay. So we have done wrong. And also we have made a great mistake, which is index out of bound. So first we have to check here that mid should not be equals to 0, as well as mid should not be equals to the n minus 1th position. And then we can only access mid minus 1 and mid plus 1. So run again. Finally, it is accepted and just going to submit it. So it is showing that you have made too many calls to mountain array dot get. So in the question, it is given that you have to reduce the number of calls. So submission making more than 100 calls to mountain array dot get will be just wrong answer. So why it is so? So here we can reduce the number of calls. So if we want to find the peak index, we do not need this particular condition, because if we will remove this condition and simply do this, so the low position will point to the peak position. If you were not consoled by me, then you can check it. So this is the check which is not important if you are finding peak. I have explained you this because I want you to know that what is the property of peak index. Okay. But if you will not, if you just comment it out and you will check this condition, so final low will point to the peak position. Okay. So by this, we have reduced the number of calls. Okay. This is the way how we can reduce the number of calls. So let me run it again. Okay. So let me submit it again. Okay. And then we'll see how it got submitted. So you can see we have got this success. So that is why I have shown you the this one, why we have got the wrong answer. Because if we will call mid multiple times, then it will give the wrong answer, because it is clearly mentioned here over submission making more than 100 calls to mountain array.get will be just wrong answer. Okay. So that is why I have decided to show you. So you can just ignore this particular statement and then you can solve the problem. So this is the another way of finding peak. So never stop whenever you are finding hard problem. Just think about the problems that you have solved earlier and that can easily map to the particular problem that you are currently solving. If you are able to map the problem, then you will break the problem into different functions that you have solved previously. Okay. And this is the way, this is the technique that most of the people do hard problems. Nobody knows each and every single problem, but there are certain patterns that we need to follow. So whenever you study some problems, try to get the core concept of that particular problem. That will help you in building the basic concept. Now you are able to find peak element and peak index. You can solve this problem easily. If in the real interview you have got the problem, you can solve it easily. Again, there can be other such problem as well. So how to approach problem that are related to the peak? Once solved peak problem, now try to see where we can apply it. Whenever you see mountain type of thing, think about the peak. If you are able to find it, just find it and try to map the problem with the peak. This is the way that people used to solve the particular problems. Okay. So I think this is very helpful for you. So thank you for watching the video.